Hello and welcome to a new edition of The Frontier. This is our once-a-week deep dive into a new industry, a new technology, or a new segment. Today we take you inside India's data center boom. Now, the world is generating more data than ever before, and storing, processing, and securing that data is now one of the biggest infrastructure challenges of our times. Back in 2019, India had about 350 megawatts of data center capacity. By 2028, we're projected to hit 3,000 megawatt. That's a 9 times growth in less than a decade with an 18% CAGR, fueled by hyperscalers, cloud-native enterprises, and an internet-hungry population.
And that hunger is only growing. Globally, we now create in 1 year as much data as we did in the entire first decade of the 2010s. From just 2 zettabytes in 2010, the world has crossed 149 zettabytes by end of 2024. And India's own data footprint is exploding. We have over 950 million broadband users. Data usage has surged from just 0.3 GB to 21 GB per user in under a decade. And Indians now spend nearly 7 hours online a single day. That's 1 full hour more than the global average. And now a new wave is crashing in. AI workloads. AI workloads are 10x to 10,000x more compute intensive than the traditional applications. That means more GPUs, more power, and a massive leap in data center design and energy needs. And that's where India is positioning itself for the next leap, with AI clusters, green energy hubs, and hyperscale ambitions.
Well, so what does this mean for India's digital future? Can our infrastructure keep pace with our ambition? And what will separate winners in this space? To answer those questions, we are joined by 2 key voices shaping this transformation. Darshan Hiranandani is chairman and co-founder of Yotta Data Services. Seema Ambastha is CEO of L&T Data Centre, both at the forefront of building India's data backbone. Seema and Darshan, great to have both of you here. Thank you very much for joining us. Let's just get some color. We put out some projections, and it depends on which projection you look at. Are they in the ballpark correct, according to you, Darshan? 3,000 megawatt in data center capacity by 2030. Is that underwhelming? Is that overwhelming? Is that overestimation, underestimation? How do you look at it?
No, I don't think it's an underestimation at all. If you look at our per capita data center capacity compared to other countries in the world, China, which utilizes the same amount of data consumption per capita as we do, already has, I think, 8 gigawatts of data center capacity. So us hitting 3 gigawatts is certainly just playing catch up. The United States is at 12 gigawatts, and they have one-fourth to one-fifth our population. So certainly, I don't think the numbers are underestimated at all. And we have actually walked the talk, as you correctly put it. We were only at 350 megawatts in 2019. And I believe we've certainly crossed 1.2, 1.3 gigawatts. Some numbers saying we are closer to 1.5. So I think we're on track.
Mm-hmm. Seema, with a current capacity of about 1.5 GB, for instance, we would be still less than 5% of the global data center capacity?
Yeah, we are. So if you see mature markets like US and China, they have built a lot of capacity. So at this moment, yes, in terms of actual capacity online, we are below. We are about 5%. But I would agree with Darshan. I think the current projections are more realistic, quite realistic, but it could be significantly conservative. So the demand for AI infrastructure, hyperscale cloud, sovereign, and all these accelerates much faster adoption. And therefore, you will see that by 2030, it could well surpass the current projections. The current projection is 3, but it should be somewhere around the range of 6 gigs. We will definitely do very rapid development. I think we have quite a few credible players, so you will see that.
But will the gap versus global peers shrink? Will we be able to close the gap? Because while we are expanding, so is US and China.
See, this market is very different how it works on the runway, right? So we are building primarily for our domestic consumption and also for the global, you can call it as cloud hubs. So these are the things that drive capacity. So we're not competing in data center capacity with the world. That's not the way it works. You're actually trying to look at what is a forecasted requirement for India and how do we bridge those gaps. It's a huge amount of capex. It's like an aircraft, right? It takes time to build it. Just can't do a 3D printing overnight. I mean, I don't think that technology has yet come. I don't know, Darshan might be working on that. I'd love to hear from him. But I think it takes some time. So given that, we will continuously try to bridge the gap of what is required for India, I think, to support that growth.
And I think that's an important point, right? I mean, it's not a competition because you're not trying to sell to the world. You are essentially trying to meet your own requirements in that sense. Darshan, you want to sort of talk to us about that? And I think the other side of that coin is why do we need all that capacity physically here within our borders? I mean, I think that is also... So let's just address both those points. Go on.
Okay, so let's first talk about the simplest reasons. First is data sovereignty, right? We should have our data in our country, and I think that's important. Second thing is it's pure economics. Today, if our data needs, data center needs, processing needs, AI needs are all being fulfilling overseas, it means every day when an Indian is sitting online, whether watching a YouTube video or using ChatGPT, they are essentially giving away dollars overseas to some company that's hosting that data, to some servers that's processing data, to some cloud that's giving it away. The third thing is when these data centers come, I mean, the numbers are only talking about 7.5 million per megawatt of building a data center. What you're forgetting is that the compute infrastructure into the data center, if it's compute, general purpose compute, your normal cloud that you put in where your website is stored, where this CNBC video is being streamed from, all of that comes at around, let's say, $15-20 million a megawatt. If you have AI compute, that's $45 million a megawatt. So when you're talking about even 3 gigawatts coming in, you're talking about 3 gigawatt, not times 7.5 million of investment. You're talking about 3 gigawatt times 30 million of average investment when you talk about CPU and GPU compute. On top of that, let me just add, you're creating a whole ecosystem of suppliers and vendors who need to manage this stuff. So when you're talking about compute, we're talking about Make in India. Today, because of the data center boom that's going in, big companies are talking about assembly of things in India. We're then talking about semiconductors being made in India. Why? You have compute capex, you have networking capex, you have all that infrastructure coming in. Today already, when I started in data centers, we were importing high-tech chillers into the data centers. Today, we're making those high-tech chillers in India. All the big multinationals are doing it. We were importing high-tech generators for data centers. Today, we're making all those generators. Everything is entirely made in India. There's no doubt about it. So what I think the entire ecosystem being created around, hey, India is consuming data, we are digitizing every Indian, there's value right to them. But look at the value in the whole chain. We have created giants like Jio, etc. on the consumption side. But on the back end side of it, we want all of that to come from India, and that's entirely critical. And I think we are there because as a company, we've the big hyperscalers in the world, they come and they build in India. But today, 50% of that money goes towards the data center and the hardware and the compute, but 50% still goes to them as software royalty. Today, a company like ours, we've built our own sovereign cloud in India. We've been contracted by, some of the major government players. We're serving India AI's GPU needs today. India has the biggest, thanks to our company, the biggest GPU cluster between Saudi and Singapore as a single integrated NVIDIA reference architecture cluster, which nobody else has. So I think we have leapfrogged in many ways. We will catch up in many ways because ultimately we want to talk about also our citizens having equity. If today an American or a European has data center compute available to them, we want the same thing for every Indian at a global standard and a global pace and of a global quality, and which we are on our way to create.
So the gap that we need to bridge is our data usage per capacity and the infrastructure, and not vis-a-vis what's happening around the world to achieve that sovereignty. Just to get some numbers in, Seema, what's the cost of building out, say, 1 megawatt of a data center capacity in India?
Anything between 6 to 7 million across the country at this moment, compared to what it was before.
Million dollars, Seema, right? $6 to $7 million.
$1 million.
Yeah.
That's right. That's right. It's 20 to 30% lower than US and Europe. So it has a natural advantage. Yeah, it's about 6 to 7 million.
So just doing
And just
sorry.
one thing, and when we say $6 to $7 million per megawatt, that is, I mean, where is that money going? That is essentially, I mean,
Yeah, it's
like the concrete structure, or is it?
no. It's into three components largely. Number one is, of course, the land. In some cities, the land is not a very major component, but in some, it's a significant part of the whole, the whole cost of capital. The second is the MEP, which is the mechanical and electrical. Oh my, that is the huge chunk. That's about 55 to 60%. And then comes the statutory and others, which is about another 5 to 7%. And then, of course, the operational cost, which is about 15 to 20%. So the major cost is your MEP, which is your mechanical, electrical, and plumbing.
This is the wiring and everything else, which basically is a large.
It's not wiring. It's not wiring. It's like a huge amount of infrastructure that goes in. I think
Right.
Darshan talked briefly about it, like the best of the chiller ecosystem, like cooling systems, your captive power systems, your gas-based power, gas insulated power substations, which you need to build beyond 30 megawatt, or 20 megawatt, you need your substations within. So you have the major substations of the state, and then you have your own substation. So that's a substantial cost. All the plumbing that you do are substantial cost. Network is a huge cost. So all these are part of your MEP infrastructure, which is the major component within that cost breakdown.
So $6 to $7 million to build 1 megawatt. So just doing the math, approximately, should we say that in 5 to 6 years, by 2030, we should be seeing inflows of $20 to $25 billion into India's data center capacity build out? And where is the money coming in from? Because we see a lot of interest from foreign investors, institutional investors. And what is the kind of return one would make?
Yeah, Darshan wants to answer this.
I can happily answer that. Firstly, as you know, there's been no shortage of capital coming into this asset class. So between foreign equity, domestic equity, foreign debt, domestic debt, I think data center is probably one of the most sought after real estate asset classes there are globally. And certainly India is no exception. So I think in terms of capital coming in, there's absolutely no issue. In terms of your numbers, you're correct. 3 billion of 3 gigawatts of data center capacity would certainly require that amount in data center build costs. And don't forget that on top of that, there's the compute costs. So in fact, this whole sector will see close to 100 billion of investments by 2030, not just 20 billion, because a data center on its own means nothing. It's only the customers putting in compute infrastructure, whether they're hyperscalers, whether they're enterprises, whether they're cloud providers, that completes the asset. I mean, I can't have a commercial office building without a tenant doing the interiors and fitting it out.
But it's emerged as an asset class, as Darshan said, right?
Absolutely. And Darshan, I think you told me earlier, without the customer putting in the stuff inside, right? I mean, it's like a power shell. It's like a concrete power shell, empty, but so it needs to be populated. Seema, you wanted to come in?
Yeah, I just want to add to what Darshan. I think you had two parts to the question, so let me answer one. As you rightly said, I think it's seeing domestic debt and, of course, the private equity, who is very, very interested in this absolutely, unstoppable, unprecedented growth in the market that we have seen. The second thing is on the returns, right? So currently, I see around 12 to 14% by itself from the data center asset class in terms of IRR, in terms of returns. But I think if you look at the value chain and if you grow up the value chain, then you will see your returns improving drastically, right? So like cloud, AI, maybe quantum in future could completely change this economics from IRR perspective.
That was an insightful discussion, but don't go anywhere. On the other side, we'll continue this conversation. Well, Welcome back. You're watching The Frontier and we're in conversation with Darshan Hiranandani of Yotta Data Service and Seema Ambastha of L&T Data Centre.
Let's just simplify that for our viewers and briefly, Darshan, if you can tell. So you run, say, for example, a data center in Panvel, right? I am a customer, I come to you, and I want to rent space. I want to rent space for my usage. So I pay like a monthly rent and everything else is taken care of. You will give me the chips, you will give me everything. So I just come in, to simplistically distill it down, it's like WeWork. I come in, everything is fitted out for me, and I rent the space and I start, it's plug and play. Is that how it works?
That's certainly in my case. In nobody else's, in India's case, that is so. So I'll be very clear about it. So we are a full stack company. You can come to us. You don't need to come to my data center. You can go online, put in your username, password, and you can put in any KYC norm, and you can get cloud compute tomorrow morning. So there's absolutely no issue of any kind. You want CPU cloud, GPU cloud, storages, databases, AI workloads, serverless, inferencing. You want to learn how to train a model, tune a model, understand a model, no matter what, we can give it to you full stack. So that's us. But take a step back. For most data center companies, what would end up happening is companies would rent out space in the form of you can take a shelf, you can take a full rack, you can take a cage, you can take a hall, you can take a floor, you can take a building, right? So typically you would come in and say, hey, my IT department is telling me we need 30 racks. And what we would give you is we would take your design and say, okay, these 30 racks are suitable for you, and then we would rent out. So you would pay for us a rent. Typically, they would then check your power, how much you're using, and you would pay your power bill on actuals. But this is where you're bringing in your own compute hardware. In our case, we actually give companies the option where we can give you the hardware, you can bring your own, or as I said, you can just get it on the cloud.
I see. So, I mean, of course, if they use yours, then the cost, you add the cost to that. And just one thing, you said CPU and GPU. I mean, GPUs, of course, the NVIDIA chips, of course, we all hear about them. And those are largely for AI usage, right?
So I mean, now, earlier GPUs were entirely used for rendering, animation, and things like that.
Yes.
They've now evolved, of course, into being the most efficient way to do AI workloads. So the whole world is now, GPUs have become synonymous with
and you said you operate one of the largest clusters of GPU between Saudi and Singapore, as you put it. Are these chips available easily? I mean, or is there a shortage? I mean, is there a long waiting list now?
The chips have a lead time still. They are available, but it takes 6 to 9 months to get these chips and put them in and get the cluster. But it's getting the chips is easy. Operating the chips as single large superclusters is extremely challenging. And I'm proud to say we are probably one of only 6 companies in the world who've got a self-service cloud available with GPU infrastructure where we can take 4,000 GPUs, make it into one supercomputer, and we can take 4,000 GPUs and subdivide it into 400,000 mini computers and of different sizes and scales for people to use. So that's a technological innovation at our end that we've put together and made happen.
So Darshan, give an example of the kind of rents one needs to pay for end-to-end usage and service.
So I'll tell you very simple. So let's say, for example, somebody is just taking a data center capacity itself. Market rents are around $70 to $90 per kilowatt on a bulk space. And for smaller spaces, it's about 90 to 110. So it's in that range, depending on the size of space that you're taking. On the second end, if you're just taking cloud compute, I think it's fairly exhaustive in a list. You just want a machine. Do you want storage? Do you want a database? You can price it. You can pay per hour. You can pay per month. You can pay per year. You can sign up for 2 years. So they're usually it's just an online calculator. And even if you go to our website, it'll give you a comparison between us, Amazon, Google, Microsoft, and you can choose whoever you want to, and they'll give you a price. The third is when you take AI workloads. India AI ran a very large mission, as you know, and AI workloads in India are amongst the most cost efficient in the world. But typically, you pay around $2 to $3, depending on the kind of GPU you're taking per hour, because it's not just taking the GPU, there's storage, and there's a whole bunch of other things. But it's not just about buying a server and renting out a GPU, it's actually having the architecture to be able to give you hundreds of GPUs that can work as one, and that's important.
No, absolutely. If you can, Darshan, very quickly, briefly, since we are in the last leg of the program, Seema said there is the physical infrastructure, there is sort of MEP, there is the other stuff in terms of how you break down the value chain, right? I know of lots of investors who've sort of put in money into companies on the MEP side, which is that 55% as Seema put it, right? Which is the cost. Is that where bulk of the value add is going to happen from an investor point of view? Are we going to see, is this market fragmented? Are there clear leaders in, catering to each of these segments? If you can give us a quick sense.
Look, I think the reality is, I think the MEP players focusing on this will certainly do well. Undoubtedly, I think investors are smart. They've got that right. I think I'm hoping more data center players will enter the public markets at some point in India, so that itself becomes an asset class. And I think the third piece is, China was run by Amazon, Google, Microsoft Cloud till a few years ago, or at least their softwares. And now they're entirely run by Ali Cloud, Tencent Cloud, Huawei Cloud, right? And the entire market is taken over. So I think, and those have become juggernauts of companies. We're talking about 30 billion in revenues to those three players just in cloud compute revenues, right? So substantial amount of money. And ultimately, we believe that we have made a play into the public cloud space with that in mind, that domestic public cloud players can and ought to be created, both from a data sovereignty perspective, but just pure economics and the opportunity available.
But as of now, when you look at it, India in a way can't match the depth and demand that's coming in from homegrown Chinese cloud providers. India's cloud ecosystem is still in its nascent stage, still maturing and developing. But Seema, getting back to, we've spoken a lot and at length about the investment opportunity. But are there any risks, any bottlenecks to us achieving our potential?
Primarily two things. One is, I believe overbuilding is always kind of a cyclical risk. I think we need to evaluate that. It's a huge disservice to the nation when you don't really build just in time, right? So that's one part. But the current demand signals are the way around, so that risk can be mitigated, right? Be it, again, AI, sovereign, whatever is robust and growing. So I think it's key to build modular, and it's key to build to just-in-time philosophy, and also to build in right places at right time. So it's very, very important. Right product, right place, right time is very important. That's one way of looking at the risk which we have. The second, of course, is the technology. Briefly, Darshan did speak about it, which is like disruptive right now. What I see is liquid immersion cooling, or say optical interconnections, edge AI, all these are highly disruptive. What kind of product you are bringing to the market, how you're complementing each other in this space. See, it's about competition and complementing. So everybody doesn't build the same product here. People build different kind of products to basically complement each other. So you compete less and complement more. And that's how it should be done, right? So you can mitigate some part of the risk. So the way the opportunity lies, of course, is you should be deeply focused on future-ready architectures, include like support for GPU clusters, ultra-high density cooling, ultra-hybrid cooling. I think these are the opportunity spaces for the data center players.
Darshan, 30 seconds, sort of same question to you.
I think like every business, you have to be nimble, smart, aware of your competition. But I think only thing holding us back is vision and mindset. That's it.
Okay, that's 15 seconds. Cool. So got 15 more left. Just the technology challenge. I mean, it's a fast changing landscape in that sense, right? I mean, chips get efficient all the time, And there's some of the other stuff which Seema mentioned as well. Are those risks that you build out with something and then tech changes and then you sort of, left holding the proverbial bag in that sense? What's your sense, Darshan?
Absolute opportunity.
Okay.
We pride ourselves in working with customers from around the world, meeting cutting edge technologies, and actually because Yotta, we have an entire in-house engineering team that's extremely competent.
Okay.
You can come and see our data center in the same building. We have conventional air cooling, we have full liquid cooling, we have rear door heat exchanger cooling, we have direct to chip liquid cooling.
No.
in
My
the same
question was
building.
not so much Yotta. My question was industry. I mean, the industry is kind of sort of, it's disrupted by
Listen,
fast-changing technology.
you want me to tell you the biggest risk. The biggest risk is people watching this program thinking, hey, this is going to be a great asset class. Let me try and start building a data center tomorrow morning. I think that's going to be the tough one. But I think if you go, the devil's are in the details. If you work hard, you have a trial by fire, and you learn what's going on, it's actually a great asset class to be invested in and to work towards. So it's not an easy asset class. There is a reason why it's being rewarded is because it's actually a hard and tough business.
Seema, you laid out the potential risks, right? Two of them, twin. One is overcapacity and the other one is technology obsolescence, in a way. These are the potential risks. Do you think there is actually a risk?
With the current, what I see as demand demand signals, I think risks are low. As rightly told by Darshan, the entry barrier is very high. So I think, that's what you should look at. Unless you really have, if you have a short-sighted, short vision, myopic view, this is not the place to be in. It's an opportunity for you to stay and mature and grow at this asset class with a lot of patience and right amount of intelligence, market data. Yeah,
I think that's very well put. I don't think Reema and I are going to start a data center business, but I think what we will do is, as Darshan pointed out, go to their website and check out what is available and what one can do. So really helpful conversation, I thought. And I think we'll wrap this up. And maybe we'll have one more episode because, I mean, we've just barely scratched the surface here. But I think one thing is clear. Data needs are exploding and data centers are the future in terms of the infrastructure and physical background, which is very much required to support all of that growth. Seema and Darshan, thank you very much for joining us here on this program. Really appreciate it. Thank you.
Thank you
for having
Thank you.